This is a recording of my thoughts on the summarizing questions for PC Activity 9, which is all about solubility. Again, as I did in the previous video, I'm not going to write many of my answers down, but I'm instead going to talk through my thoughts on each of these, and you can hopefully use that to compare to your responses if you answered these questions. Question number 1, say restaurants that offer sweet tea on their menus usually make it by adding sugar to freshly brewed hot tea as opposed to adding sugar to cold or iced tea, and why? And the whole reason for that is you can dissolve more sugar into hot tea, or the dissolving happens quicker in hot tea. So from a particle level, we imagine that in hot tea, the particles are moving much more rapidly. And so when you dump some sugar into that, the particles of tea are going to break up those sugar particles faster and distribute them throughout the liquid. But it also turns out that you can actually put more sugar into something that is at a higher temperature. The experiment done earlier in this activity showed that different amounts were dissolved in the flasks that contained hot water, room temperature water, and cold water. And for most solids, the higher the temperature of the liquid, the more of that solid is dissolved within the liquid. So, yeah, I don't know if it's to get the maximum amount of sugar in or they just want to do it as quickly as possible, but both of those things could be true. Summarizing question 2, what should happen when a solution of dissolved solid in a liquid is cooled? For example, hot sweet tea is refrigerated, and explain your reasoning. Well, it really depends on how much sugar you've put in there, but let's just say you are a restaurant owner that wants as sweet of tea as possible. So you make your hot tea and you keep on dissolving sugar into it until you cannot dissolve anymore. And you know it's dissolved when it disappears, right? You can't see it anymore in that solution. And so at some point, you won't be able to add any more sugar to it without that sugar just falling to the bottom of the container, because now your hot tea is holding as much sugar as it possibly can. So if you really have maximum dissolved sugar in the hot tea and then you go and put it in a cold environment like the refrigerator, cooling that liquid will lower the solubility of that liquid. And so some of the sugar will actually fall out of the solution and you will find it on the bottom of the container later, because again, there's a link between temperature and solubility. Summarizing question 3 said you have seen a model of sugar dissolving in water in exploration number 5. That's where they give you the picture of basically the sugar cube, particles dumped in water particles, and then the dispersing of the sugar particles throughout. Think back to the charcoal mixing in the water. Charcoal is considered insoluble in water. When we stir up the mixture, the charcoal appears to be suspended in the water, but eventually settles out. We were also able to filter it, and we refer to these types of mixtures as suspensions. So it asks us first to give an example of another suspension you've seen before. Those can vary widely. The one that always comes to my mind is if you've ever walked in a lake or a slow-moving river or whatever and stirred up the bottom of that, you'll get dirt that's swirling around you, and sometimes enough that you cannot see the bottom. So that's what I always think of when there's a suspension, which is dirt in water of some form. An example of a solution I've seen before. Well, we were just talking about sugar and hot tea, so I suppose that is a solution that I've seen before, but also salt in water. You can mix salt in water to gargle or use for various purposes, so that's something. Other kinds of solutions that I've seen before. Technically, you get solutions also when you mix a liquid with another liquid, and so pouring two liquids together but getting a single liquid that has a single set of properties is also an example of a solution. How can you decide whether something is a solution or a suspension? It really comes down to if you can see the particles in there still. So if you can still see the particles floating around in there, like the charcoal, or like if you have sand or dirt in water, that is a suspension because the particles of whatever you've put in there are not small enough to basically disappear into the liquid. And something is a solution when you no longer can see those individual particles floating around in there, and the whole thing takes on a uniform appearance. Now, that uniform appearance may be different originally. So technically, if we mix like food coloring into water, that is a solution because the food coloring, you can't see the food coloring particles in there anymore, but it has changed the appearance of the water in doing that. And so the difference really comes into whether you can see the particles and also often whether you can filter them out. And recall in the videos for this particular activity, they did filter the charcoal out of the water using that filter paper right there. How is the arrangement of particles different in a solution and a suspension? Used well-labeled diagrams to illustrate the difference. Well, I don't know that I'm going to be well-labeled, but if I had a solution and I was hiding my green particles within my water particles, I would expect that those green particles would be well spread out among many water particles so that basically I can no longer see what the individual substance is that was represented by my green dots here. Whereas, if I had something else that didn't dissolve in water, I expect that, to some degree, those little particles of that thing still stay with many, many particles actually stuck together in the form, so that even though they're there among these many water particles, they remain large enough that you can see that substance within the water. Difference between a suspension and solution, well, we've talked about this already. It's the visual appearance, and it's whether or not you can filter the material out of there. If you can, it's generally a suspension, and if you can't, it is a solution, which I find redundant of parts of summarizing question 3.